So this is lesson number 34 in Algebra 2, and this one is called Uniform Motion Problems. And what I want to do first of all is look at what we've already done. At present, we have looked at the distance traveled by one person is the same as the distance traveled by the other. So sometimes they go the same place with the same starting point. Some start at one starting point and go a distance. One starts at another starting point and goes back. Or maybe you ran this far and walked back. So the distance was the same. The second set we did is the distance, let's say that the distance you ran plus the distance that you walked equals 480. Or two people started from the same place. One went this way, one went this way, but when you add the two distances together, you get the total 480, just like you did here. Distance 1 plus distance 2 is 480. Distance 1 plus distance 2 equals 480. Or one person started here and one person started here and they met in the middle. That distance plus this distance equals 480. Okay, so that's what we've done so far. Alright, this next section is a little bit different. But in this section we have a third method that we're doing. Okay, one is, let's say that you went this far and another person went this far. So if you added this distance with some number, in this case 40, you would get the distance the other person went. Or maybe this person started at 10 o'clock in the morning and started traveling, and by 2 the other person started, so now you're both going the same time, but the distance this person went before this person even started was 40. Okay, so that's what we're going to be looking at this time. So let's start with our first example, 34.1. So one of the key things to remember is D equals RT, because we're dealing with distance and we're dealing with time and rate. So the distance that Millicent went is going to be her rate, we'll put an M there, times her time. Put an M there for Millicent. Beauregard began to chase her, so we've got distance of Beauregard equals his rate times his time. Okay? Alright, so Melissa began her journey at 6 a.m. So 6 a.m. And she went 50 kilometers per hour. So the rate of Millicent, whatever her name is 50. And Beauregard began to chase her at 10 a.m. So he started after her 4 hours later. And his rate was 60. So we need to know what time it was when Beauregard got within 40 kilometers of Millicent. So see, we're using this one here. So Melissa, she started and she headed out. They both started from the same place and she headed out. And Beauregard started later. And they want to know what time it was when Beauregard got within 40 miles. So he was still 40 miles away there. So it really helps to make a cool little chart and have something like this, because I can say the distance of Beauregard plus 40 is going to equal the distance of Millicent. So the distance of Beauregard plus 40, because when they stopped, Beauregard was still 40 kilometers away. So in order for it to be equal, in order for him to go the same distance, he'd have to go another 40. So I took his distance plus 40, and then that equals her distance. Alright, and then I do my rate times time. And that's plus 40 equals the distance would be rate times time. Okay, so see what I did there? I just changed distance to RT for Beauregard. Distance for Millicent is RT. So I've got that. And then I can start filling in the blanks. So rate of Beauregard is 60. we don't know anything about time, plus 40, and the rate is 50 times tm. Alright, so let's move some stuff around here. And we can move this up and move that up. Give myself some more space here. Okay, so notice what we have here. I have a TB and a TM. I have two variables. Don't like that. I can't solve this when I have one equation and two variables. This is my equation. So, what do I know? I know that, what's her name? Millicent started 4 hours before Beauregard. So the time that she was on the road was longer than Beauregard by 4 hours. So if we take Beauregard and add 4 hours to his time, then they become equal, right? Because hers was 4 hours bigger. Sheesh, all kinds of weird noises coming from here, aren't there? Alright, so now what we're going to do is whenever we see a TM, we're going to put that in its place. So then that will give me one nice variable in our equation. Like that. Now we can distribute. Okay, and then subtract 40. You know the routine here. Let's go away. I'm going to move this over by subtracting the whole thing from both sides. Now let's see if I can move that up. Okay, sorry that looks really weird, but this is where we ended. I just was subtracting 50 from both sides and I moved everything up. So that leaves me 10 TB equals 160. Those go away. And what we found there is the time that Beauregard was 40 kilometers away. And that would have been, well, what does it ask? It says, what time was it? Okay, so the time was 16 hours after 10 o'clock when Beauregard started. So what they're interested in is 2 o'clock a.m. the next morning. Okay, so they didn't just want the time that Beauregard was going, they wanted, if he started at 10, 16 hours later, what time was it? Alright, so that's what we're looking for there. Alright, we'll do one more problem, and we'll do that on the second video for lecture 34.